Okay, here we go. This is section 11.2. We're going to talk about a couple more area things. Yesterday we talked about the area of a triangle and the area of a parallelogram. So this time we're going to talk about the area of a trapezoid. Then we'll talk about something else in a minute. But first of all, we're going to talk about a trapezoid. So let me grab a trapezoid here. And I just happen to have one. There it is. How's that trapezoid for you? Now we've talked about trapezoids earlier in the year. Remember that chapter we talked about parallelograms? One of the sections in that chapter was about trapezoids. Now a trapezoid, just to remind you, has exactly one pair of parallel sides. In this case, that would be the top one and the bottom one. All right. They define those two parallel sides to also be the bases of the triangle. Not triangle, trapezoid. Okay, so that would be a base, and this would be a base. We'll call that base 1. And we'll call that base 2. So the parallel sides are considered the bases on a trapezoid. You can't just say, oh, that one and that one. You can't just say any two bases or any two sides are the bases. You have to talk about the sides that are parallel to each other. Okay? So the parallel sides are the bases. Make sense? What's that? What would you say? You said something, didn't you? I thought you just said something. You didn't? I was sworn I looked at you. You said something to me. Okay. My mistake. Alright. Well, what else does this have, this trapezoid? What do you think that would be considered? If that was perpendicular. Be the height of it, wouldn't it? Okay. So the height, just kind of like the parallelogram, right? We did the parallelogram yesterday. We went, the distance between the two parallel sides would be considered the height. Same thing here. This would be the height as well. Alright. Now, if you look at a trapezoid kind of, even though it's got four sides, it kind of resembles a triangle a little bit. Do you think?
Yeah, like someone was chopped off the top.
Exactly. Okay, that's exactly how I said it in my last class. It's kind of like it's just chopped off the top of a triangle. You guys are watching, right? Up here. So watch, if I extended this up like this, and I extended this side like this, guess what it would form? It would form a triangle, wouldn't it? Except, just like Kelsey said, if you just chop off the top of it, parallel to this base right here, okay, it can't just be chop it anywhere. If you just chop it off parallel to this side right here, then we've got a thing called a trapezoid. So it's very similar to a trapezoid. In fact, triangle and trapezoid start with the same two letters, don't they? So the formula is also very similar, not because they both start with a TR. That has really nothing to do with it. Okay, but it just happens to be that these triangles are these areas are very familiar, very similar to each other, I should say. What was the area of a triangle from yesterday, quickly? Area of a triangle? 1/2 the base times the height. So look at this. This doesn't just have one base, though, does it? It's got two bases. What do you think we're going to do to those two bases? So here's 1/2. The base. Well, we have a base 1 and a base 2. Guess what? Add them up. That's right. If you just add up the two bases, so it's very similar to the area of a triangle. The area of a triangle is 1/2 the base, and only has one base, right? Times the height. This is 1/2 both bases added up. The sum of the bases times the what? Times the height. I just looked in the book. For some reason, they put the height right after the half. I kind of like this way better because it's very it just looks very close to the area of a triangle. We already know the area of a triangle, so we can just write it like this. Base 1 plus base 2. Isaiah. So it's 1/2 the base times the height. Except a trapezoid has two bases, doesn't it? And that's the formula for the area of a trapezoid. Pretty simple. Now look, if they give you a base and a height, and they ask for the other base, they give you the area. There's all kinds of things that they could ask you here. Now, if they give you both bases and the height, it couldn't be easier, could it? Just plug stuff in, okay, add up the bases, multiply by the height, divide by 2, and you've got the area. Okay, they could play around with this a little bit. Sometimes they might give you the area. Remember a problem yesterday? They gave you the area of the triangle, and you had to find one of the bases. They could do that thing here, too, if they want to, right? So you know how to do that. It basically just comes down to some basic elementary algebra. Just throw the numbers in this, whatever they give you, and then solve for whatever they ask for you to solve for. Okay? All right, that's all there is to that. Let's go to another one. That's trapezoid. Very, very close to the area of a triangle. Let's see what's next. Okay, here's a new area. This is the area of a rhombus. So let's write that down. We studied rhombus before because a rhombus is just another type of what? No, it's not a rectangle. It's not a square because it doesn't have right angles. Parallelogram. Thank you. It's a parallelogram. Okay, a rhombus is another type of parallelogram. All right. Not every rhombus is a square or a rectangle. Is this a square? Is it a rectangle? No. So you can't say the rhombus is a rectangle or a rhombus is a square. Okay, but you can say a rhombus is a what? Parallelogram. Okay. Now, we've already talked yesterday about how to find the area of a parallelogram. What was the area of any parallelogram? It was real simple. What was it? What was the formula? Just the base times the height. Okay? So you're looking at this and you're saying, well, it's just the base times the height. Figure out what the height is. It's that perpendicular distance. Okay? Multiplied by the base. You're good to go. But what if they don't give you the base? And what if they don't give you the height? What if they give you other stuff? All right? You can still use it. I'll show you. Let's draw a diagonal. Okay, I'm going to go from corner to corner. That's a diagonal. Okay, we've talked about that before, haven't we? Now, what do we know? Before I even draw that other diagonal, what do we know is true about the diagonals of a rhombus? Are they congruent? Is that what we learned? They intersect how? How do you think? They bisect each other. Okay, well, that's true about any parallelogram, but more specifically about a rhombus, though. Are they equal to each other?
Are you talking about both?
I'm talking about the two diagonals. I'm talking about the two diagonals. They what? They make a 90-degree angle. Give me a better word than that, though. They're perpendicular, right. They're perpendicular. So watch. There's my two diagonals, and what's true about them? They're perpendicular, okay? Now, what if they give you the lengths of those diagonals? Okay, or they could just give, what else does it do? Remember, this is a parallelogram. Diagonals also do what else? In any parallelogram, what do they do on every single parallelogram? They what? They divide it up. Divide it up how? That's right. They intersect each other at a midpoint. Okay, so they bisect each other. All right, that's the phrase that we used back when we did that chapter on parallelograms. That the diagonals of a parallelogram bisect each other. So this and this would be equal. This one and this one would be equal. You follow me? Okay. So, I mean, they could give you all kinds. They could just give you this distance from here to here. But what we're talking about the whole entire diagonal. I'm just going to do this. I'm going to put D1 for diagonal 1 because there's two diagonals here. Now, if I just put it here, that's talking about the whole entire thing. In fact, let's write it down like this. So D1 would represent what length here? DB, right. So D1 represents that whole thing. I could put it like a little line here, and arrows in between, but it makes it too messy, okay? So I'm just going to do it like this. So this whole thing is D1, and then AC, what do you think we're going to call AC? Call that D2. Now you understand, D2 just doesn't go from here to here. It's the whole entire diagonal. Make sense? All right, so you've got D1, you've got D2. Now watch the area of a rhombus equation. The area of a rhombus, it starts off with 1/2 again, just like the trapezoid, just like the triangle. Now what you do with these two diagonals is you multiply them together. So it's D1 times D2. And that's it. That's the area of a rhombus. We're not going to go through any kind of proof and show you, why that's true. I guess you probably could. You could probably figure out, well, this is the base. What would the height be? The height would be like from here to here. You might be able to do some stuff to figure out how to get that. At this point right now, it doesn't really bother me that that we know how we got to this. All right? Maybe in upper level math you can see that. Okay? So that's how we find the area of a rhombus. You just take the two diagonals, the whole length, from AC and then from D to B. You get it? You multiply them together, but then you're not done. What do you have to do? Take half of it, right? Take half of it. And that's how you find the area of this, not even knowing the base and not even knowing the height. You got that? Okay. Now, what if they told you the base and you could figure out the height, or they told you the height? Then I would use that equation, wouldn't you? Right? Sometimes they don't give you the diagonals. Use the base times the height. Sometimes they don't give you the base and the height. They give you the diagonals. Then use this one. Right? Because a rhombus is a what? It's a parallelogram. So anything that works with a parallelogram would work with a rhombus as well. All right? Let's do another type of figure, and then we'll be pretty much done. Maybe we'll do an example before we get out of here.